right. Alright, count the number of powerful integers. Hard one. You're given integer, 3 integers start, finish, and limit, and you're given a 0 index string s representing a positive integer. Positive integer x is called powerful if it ends with s. You get 3 integers and 0. In other words, s is a suffix of x. And each digit in x is at most limit. Alright, return the total number of powerful integers in the range start to finish. So you have a range that you're given, and you have a limit value. The string x is a suffix of string y. A string x is a suffix of a string y if and only if x is a substring of y that starts with some index in y extends to y. Okay, well, suffix I think is just the opposite prefix, it's just ending. So you have start and finish is 1 to 6000, limit is 4, and s is 124. S is the suffix. Powerful integers in the range 1 to 6000 are 124, 1124, 2124, 312. Okay. All these integers have at most 4 digits, which I guess is the limit. And 124 is the ending of that. Okay. Note that 5124 is powerful, but because the first digit is 5 is greater than. Okay, 4 is not the number of digits, it's the first digit. And each digit in x is at most limit. So 4 is the maximum digit within the number. Okay. So if it's 15 to 215, limit is 6, so it has to be 1 through 5 digits. And 10 is your suffix, so like I'm guessing 110 and 210. Okay, 110, 210. And here the limit is 4. Is the limit always a digit? Each digit, yeah, okay, limit is a digit. Alright, and then 1000 to 2000, the suffix is 3000, that can't possibly occur. Alright, and the limit is 4. So, interesting. So you have numbers, start and end numbers are pretty large, 10 to the 15th, that's bigger than a normal integer, I think. And then the limit is 1 through 9. Okay, it's a digit. Alright, so what to do here, what to do. So you have, I guess you can start by identifying the number of digits that these things are dealing with. The number of digits. Because the number of digits kind of, or maybe you can start by doing the trivial case where you identify if it's possible or not possible. Identify all the total number of powerful integers, so you're not trying to figure out what the powerful numbers are, just the number of them. The number of powerful numbers. Okay, so that makes it a little easier since you can just logically deduce some of it rather than having to actually construct it. Okay. So let's take the example here. So let's say the example is the 124. So it's the start is like a 1-digit number, and the end and the finish is like a 4-digit number. So you have 1, 2, 4. If you have 1, 2, 4, that's 3 digits. And so you have like some numbers here, right? You have some prefixed number, prefixed digit, and that can cycle through, like, that number is, if it's just the leading prefix, it can't be 0, but normally it could be 0, or otherwise it could be 0 if it's multiple ones. But you can have 1 through 4, since the limit is 5. And if it was something where the limit was, let's say, if the finish was bigger, then you'd have multiple digits leading. Like, let's say, the finish was like a 5-digit number, 5-digit cap. Then it'd be like 1 through 4, another 1 through 4, like, so like this thing is 1 through 4, no, actually, yeah, 1 through 4 is the leading digit, plus say 0 through 4 is your second prefix digit. So that's like 5 times 4 possibilities. Interesting. Wonder if this is possible to just have a formula for it, or do you have to do some sort of recursion? String axis. Now, why is this difficult? So for each digit, so I guess you could go through I guess the start and finish is not trivial. The start and finish isn't trivial. Like, it's just a number of digits. It's a number of digits plus some offset within that number of digits, possibly. Like, this is start is 2 digits, then it's 15 within 15 offset within that. And you really want to do this quickly. Okay, the suffix. So you start with the prefix of 0 and see if it's bigger than your start. Okay, let's try something brain dead. So if the value s has a length of can s even be converted into an integer? I think so. If the int value of, let's say, s num is the integer value of the string s, and if s num, if the start is less than or equal to s num is less than or equal to finish, then we'll say that counts as 1. Let me just check that code works. Alright, 1, 2, 4 is between 1 and 6,000, returns 1. 10 is not between 15 and 215, so returns 0. 3,000 is not between 1,000 and 3,000 and 2,000, so it returns 0. Okay. So this is just counting the prefix 0. And for bigger numbers, the start and finish can be, I guess this doesn't quite work as well because this could technically, the string s could actually be above. Okay, no, s works as a limit, so it's not trivial. So going from a prefix of 0, having no prefix pretty much, and then going through all your other prefixes, as long as it's below your finish. I think for each, let's say, okay, so let's say there's like a really big range here. Let's say start is 1 and finish is, well, the biggest there is like 10 to 15th. And let's say you do 1, 2, 4, and your limit is, let's say limit 7. So that means 10 to the 15th means there's like 10 digits possibly. But 10 digits or 15 digits possibly, or is it 16 digits? 10 to the first is 2 digits ending in a 1, and then 10 to the 15th would be 15 digits, not including the first one. So 12 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so let's say that this is the deal. How would we go about doing this? So if I were to identify for each spot how many things can occur in that spot, this digit could be 0 through 7. Is it limit is inclusive? Yeah, inclusive. So this thing could be 0 through 7. So there's 8 digits here, 8 digits here, 8 digits here, 8, 8, 8, 8, 8, 8, 8, 8, 8. So I think that would be something like 8 to the power of 8 to the power of 12 plus 1 as your answer. Right, let's do a test case here. So start is 1, finish is the biggest there is. So it's 1 and then 15 zeros. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15. Let's say the limit's 7. Alright, and let's see what the correct answer is here. Okay. 8 to the power of 12 plus 1. 687. So I think I'm off by 1. Is it literally 8 to the power of 12? 687,194, 76736. Why is it? Why wouldn't it be? I thought maybe not having a prefix was counted an extra 1, but it's just 8 to the power 12. How odd. So if it was all zeros, okay, let's try if it was 1,000, or let's try it was 5 digits. So okay, so let's say it was 10,000. So this is 8 times 8. It's just 8. So if it's 10,000, it'd be 1 some number, then 124. This answer is 8. So it's like 124. Oh, interesting. Oh, I think it's because I'm actually going above. Like if it's 10,000, it shouldn't actually have all these zeros and then 124. So that counts as pretty much all the zeros in 124. And that's the only one that actually goes out of bounds in that fashion, I think. So that's going to give me a rough estimate. That doesn't really do the numbers of digits correctly, or not. That works for like maybe some even power of 10, but it doesn't work for like 15 as the starting, or 25 as the ending, or something like that. Okay. All right. So, but maybe I can do, if I can do that as a rough estimate, and then do some fine-tuning of that calculation. All right, so let's say, so how do we approach this? You have a number of, you have to identify like, or I want to identify the number of possible digit spots. So I'll do something like, let's say finished digits is going to be log the integer of the log of the number base 10. Is that a thing in Python? This Python log base 10. What is the actual? I should be better at this. log function. Oh my god. Okay. So it's log x in the base, or I can do log 10. So let's say f digits is finish base 10, enter that, and s digits for start digits is the integer log finished, and just print out currently what these things give me, just to double check. Finish. Uh, 10 to the 15th. I think this was 10 to the 15th. And that gives me 14 digits. Log base 10 to the 15th should give you 15, right? 100 is 10 squared, 1,000 is 10 to the third. Seems like it's off by 1 for some reason. $6,000 is 10 to the first, second, third. Okay. So the number of digits is rounding down. 10 to the first, second, third, fourth. No, I guess that's right. So let me think. If it's an even power of 10, if the number is exactly power of 10, then that works to give you the power, but the power is off by 1 in terms of the number of digits. Right, okay. Yeah, 10 to the first, power is 1, 2 digits. But if it's not an even power of 10, then it's still giving you incorrect number of digits. It's giving you 1 less, right? So I think this should be just +1. Alright. So finish is 5 digits, start is 1 digit, 15 digit, 1 digit. Finish is 4 digits, start is 3 digits. Okay, yeah, if it's exactly a power of 10, then it's correct. Then it's exactly a power of 10, then here it's to the third power. Why doesn't this give +1? 10 to the first, second, third. So shouldn't this be printing out 4? Oh, what is going on? Start log base 10. This is 10 to the third, first, second, third, +1. That's the right number of digits. That's the right number of digits. Log base 10 of 10 is 1. 10 of 100 is 2. 10 of 1,000 is 3. Log base 10 of 1,000. 3 plus 1. What is going on? Yeah, it's just, what is log base 10 of 1,000? log base 10. 1,000 is 3. 3. Why does this not give me 4 then? Integer log of my start number. S digits. 1,000. There has to be something I'm doing wrong here. Log base 10 of 1,000 is 3. Cast that to an integer, that's 3. 3 plus 1 is 4. Log of finish base 10. Log of start base 10. Oh my god, are you serious? It's fucking it's not precise. Holy shit. Okay, so I guess this is a rounding error. Okay, interesting. Is it fine for me to just round these values and hope that I get correct most of the time? I could also just do a loop and guarantee that I do it right. What am I even doing right now? I'm getting the number of digits. Alright, so if the start has some number of digits, okay, I'm gonna hope that this works. I'll do the round, then cast an int. Okay, this is, let me check correctness of this operation of log operation. Actually, I wonder if log 10 does this any differently rather than log base 10. Is it still gonna give me? Okay, so log 10 actually does it correct without rounding issues. Okay. Alright, log 10 of the start. And log 10 of the finish. Okay, so I have the number of digits. And then the suffix will take some number of digits to work with. And then I'll have some number of digits to play with for what open digits could be. So I'll say free digits is equal to, this is approximation, this is not precise right now. Free digits is equal to the F digits and I'll say digits is the number of digits in the suffix. So log 10 of string s. So F digits minus the number of digits is that right? So if your finish has 16 digits, wait, this had 16 digits? Oh wait, do I need to add +1 for these now? Or no? Start is 1, end is 5. 1, 2, 3, 4, 5. Start is 1, end is 16. Yeah, 10 to 15 is 16 digits. So if it's 16 digits, it's going to be that thing minus 1 minus the number of digits is the number of free digits. And then like maybe the answer is like roughly answer is roughly the number of free digits to the power of, or the limit to the power of the number of free digits, limit +1. Oh, and this is not really, probably not really close. This should be S-num. Oh, I could have just converted these to strings and then did the length of the string. I wonder if that would have been just easier. F digits. Okay. So this one gave 5. Let me print out what the F digits is. I don't even know if any of this is going to get anywhere close to the answer. So this thing came out with 13. But I think I expected it to be 12. But then this number is actually smaller than expected. It should be 8 to the power of 12. 8 to the power of 12. 3 digits. The number of F digits was, oh shucks. So there's 16 digits here. 16, yeah. And then you subtract 3 digits for the subtract 3, subtract 1. Subtract 3, subtract 1. Huh. Oh, it's actually +1 here. Yeah, I don't know if this is 0.2. Return value is not a integer. Return value is expected return type long. What did I do wrong here? So return answer was, number of free digits calculated here was -1. And then it did to the negative 1 power. All right. Okay. Let me see. All right. Well, the one case where I was fully examining is correct. So here, the number of finished digits is 4, starting digits 1, suffix digits 3. So, so you have 1, so you technically have 0 free digits. Okay, yeah. Because you're considering this as 1,000 rather than 6,000 if you have 4 as your number of finished digits. So if it's above, if it's not actually a power of 1 with the power of 10, then it's actually gonna want to consider the next number of digits. Oh jeez. Let's see. Yeah, maybe this just shouldn't be. It should be just the length of the string. So for each, maybe I'm just overcomplicating this. So I have a starting number of digits, and then I have some starting number of digits, which is your suffix. And if you consider whether or not it's bigger than the start, that if it's smaller than the start, then what happens? If it's smaller than the start, then it just can't. It would need to add some prefixes. So you have a starting value. The starting value. The total number of powerful integers in the range set to start to finish. So it's at most the number of digits that you're dealing with to the power of your limit, or your power, the limit to the power of limit plus 1 to the power of number of digits. So it's at most. Most is going to be digits, or limit plus 1 to the power of the 3 digits. There's probably going to be some other complication there. Could you subtract your start? Could you zero it out? I don't think so. Could you make your start so Okay, so I think maybe I need to simplify this just a little bit. So if I do a call to this function, where the function call is start, finish, limit, and s, I think I can make that into function of 0 to finish, limit s, minus function of 0 to start, limit s. So if I subtract out everything, yeah, if I subtract out all the powerful values that are below start versus all the powerful values that are below finish, from 0 to start, 0 to finish, I should be able to get the powerful values between them. So I can not worry about start as an issue. I can just worry about getting finish. So from 0 to finish, how many powerful values are there? Now that's easier said than done still. Because finish doesn't necessarily need to be a power of 10. But I just need to worry about finish. From 0 to finish, how many numbers are powerful and inclusive of the limit, or bound by the limit? I mean, it's so close. It's like 6,000, between 6,000 and the next power of 10. 6,000 next power of 10. But it doesn't have to be that. I wonder, can you subtract out? So would it work if I did finish of function of 10,000 minus function of 6,000? Does that work? Function of 4,000. Not really, I don't think. Like the digits themselves are not necessarily tied to the calculation themselves are not necessarily tied to some ranges. Like it's not. I don't think it works that way. So from 6,000 to like 100,000? No, 6,000 to 10,000. One, two, three. Well, okay. So if I have an upper bound, say the finish is 6,000, right? Can I do function to 1,000 and then plus some other stuff? So the number of things up to 1,000 and then something where the other stuff is for f of 1,000 to 6,000. Like handle those separately. Would it be easier? But then this could be something weird like 6, let's say 6125. And I guess at most I'd be dealing with is like a few one-ofs, right? It would be at most 9, I guess. for those possibilities. But the other stuff is handled within the other overall calculation. Okay, I think that makes sense. All right, so let's say if gosh dang it, non-powerful. Let's say now. If start not equal to 0, then return this thing self 0 to finish limit s minus 0 to start limit s. Okay. That might have some issue with edges, like bounds. Like it might be start minus 1 or something, but I'll figure that out later. Alright, so now I'm dealing with start is exactly 0. So I want to lower finish to the lowest, find low, find closest smaller power of 10. And I think that should be that should just be the number that should just be let me try this. String of finish, the length of that string. Minus 1? No. So the length of the string would be like 4. Power of 10 would be 3. So that would be minus 1. Actually, let's go ahead and just put that out. Alright, I think I miscalled this. I think it probably should be called with this. Okay. So a low power of 10. Why is it printing out? Oh, it's printing out twice because it's doing two separate calls there. Okay, so let's say finish is the printed out here. Alright, so this is 10 to, so 1000 is the lower power of 10. So let's say, let's do 10 to this power. Didn't quite work as I want it to. Okay, you know, that's right. So finish is 2000, lowest power 10 is 1000. Finish is 6000, lowest power 10 is 1000. 215, 100, 1510. Okay. Yeah, I think this works as I want it to. Okay. So can we use binary search? Oh, Sorry, I didn't see that message. So binary search would probably not sure what you mean. Like there would be can you use binary search? You're searching for the actual number. Yeah, so off the top of my head, it doesn't seem like I would want to use binary search here. Because binary search is, I think of it as more of if you guess a number for binary search, let's say you guess the total number of powerful numbers, you would need to be able to somehow quickly identify whether or not that guess is is good or bad. Like it's too big or too small. And I'm not sure how you construct the the evaluation whether or not a number is a good or bad number. Yeah. All right. Anyways, find the closest smaller power of 10. So from that power of 10, you would subtract, so let's say it's 100. You would subtract the number, you would calculate the number of free digits from that power of 10. So so 100 has 3 digits. So I think maybe I don't need to subtract 1. Subtracting 1 gives you 1 less digit. So let's say low closest power of 10 is this, pow 10. Bit close pow. The length of the string. And then the free digits is going to be equal to 100. It's going to be equal to that close pow minus the length of the string s. That should give you your number of free digits. And the number of free digits. So the answer should be starting with the free digits or the limit plus 1 to the power of free digits. Actually, and let me go ahead and just double check that. So close pow, 3 digits, answer. It's not doing the small values correctly. Yeah, it's not doing the small values correctly. Almost, this one's still doing the big ones still very correctly. Alright, so here, let's look at this one here. So 1, 2, 4 is your ending digits here. There should only be one free digit. So it should be close power minus length minus 1. So there's one free digits here, which is 8. Alright, that's correct. There's 12 free digits here. Okay. Alright, so that works for when the closest power is big, is the upper bound. Now when you're dealing with the start, where the start might be below your number of, that start might be below your suffix. How you want to say that the free digits should just be 0. Right? If the finish is below, if the finish number is let's say snum equals the integer value of s. If finish is smaller than snum, smaller than or equal to? No, smaller than snum, return 0. Okay, so that's good. Alright, and now it's just a matter, I think, of handling the number of values between the power of 10 and the actual finish. This is values between powerful values from 0 to power of 10. And then more values from power of 10 to the actual finish. So I think you could possibly construct those values. There's only going to be like up to 10 values. So for every digit that is bigger than 1, so for each digit in range of let's say 2 to limit plus 1. So you start with 2. I think 1 is already counted. Was 1 already counted? Oh, but this is a multiplier, right? This multiplies your answer by some amount. I think. Oof, I might be screwing up pretty badly here. So this is prefix possibilities is 1. Prefix possibility is 1. And then 1 should always work given this other code. So if the digit is from 2 to something bigger, the limit, if that number no, so I think so the issue is let's say the finish is 3 let's say the limit is the finish is 5 5 5 1 5 1 5. Okay. And let's say our limit is 4. So what's going to happen is, and let's say our suffix is 1 2 3. So we already did all the things between, like, so this is what we did all the things between 10,000 0 to 10,000 was covered in the previous answer calculation. So what we want to do here is, but the issue is that calculation, some of it can be multiplied. So that calculation was a power calculation. Like every possibility for the number of free digits for any of the digits, in this case it'd be, actually, so let's do that. So 1 2 5 1 5 1 5. The limit is for numbers 123. Oh, it's gonna crash. It's just return the answer. Expected indent. How do I remove your incorrect indentation? Am I indenting this wrong? What's going on here? Okay, let's just move this to the end. Okay, so here, for this case, the simple stuff would be like 1 5 1 5 2 5 1 5 3 5 1 5 4 5 and 5 and technically like 0 5 1 5 is counted as one of those fives. Now, if there was like another digit, then I'd be multiplying the number of ways of doing that digit versus the number of ways of doing like the number of ways of doing the 10,000th digit versus the number of ways of doing the 1,000 digit. But here, what am I gonna do? Not every way of doing everything below 10,000 will work between 10,000 and 5,000. So for instance, if it was 1, 2, 3, 4, and 0, if you add another 1 in front of this, or 2, or 3, or 4, or 5, whoops, the ending should be 1, 2, 3. It's 1, 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3, 4, 1, 2, 3. So not every single one of these ways works adding an extra digit in front. For instance, it only really works with this one, 1, 1, 2, 3. It doesn't work with the 2, 1, 2, 3. So I can calculate the number of ways of doing that first digit, where that first digit, ignoring the other digits, goes to ignoring the in-between digits, but the in-between digits to affect things. Huh. Gosh dang. Can we use binary search? Is binary search an actual thing for this thing? 5, 1, 1, 2, 3. So it's like a conditional, not independent probability, or not independent counts. It's conditional counts. So the number number of ways you can do the first digit you can do the first digit. Actually, so anything that is not actually matching, anything that's not actually matching the finished digit is still going to be smaller. So even if it doesn't have to be all the digits. I think I'm confusing myself. It doesn't have to be that all the digits are correspondingly smaller than the other digit in the number. It's just the overall number. And the overall number, as long as the biggest digit is still smaller, then that number will be guaranteed to be smaller than the finish. Like if the biggest digit is 4, then regardless of the other digits there are, that's going to be less than a 5. So I can multiply it by most of it, and then obviously there's the non-trivial edge case of the biggest digit matching. If the biggest digit does match, then then the second biggest digit needs to be at most the second largest, at most smaller than the second largest digit. So you could do something where you look at the number of values where your second digit is the look at the number of powerful values between 0 and your second digit, 10 to the power of your second digit, or so. Okay, so let's say the finish was something like this. So let's say the test case was actually 21515, and this is smaller than 1, 2. And the limit is still 4. Alright, let's see if I can't piece together what the answer should be. So 21515 limits 4. Okay. So there should be just 2 free digits, the hundreds and the thousands place. So that should be 5 times 5. And that gives you 25. Okay, so like 2, so 1xx 1 5, or 1xx 1 2, that's 5 times 5, which is 25. Now the other one is, bro, this is too hard. I agree. 2, so the first, I'm struggling with time limit. Well, are you giving yourself a time limit? So it's going to be 2xx 1 2. It's going to be, so if you have 1 or 2 in your first digit, 2xx 1 2. So that should add another duplication, so that should be 25, 25, so that would be 50. But the actual answer is 60. The actual answer is 60. So what's going on? So I guess it could be, I mean 0 xx12, 1 xx12, 2 x1. Maybe this is the way to approach it. Because 0 is actually what is being considered when I do power of 10. So this is actually, yeah, so this is like 75. And then you reduce it by the things that don't work between 20,000 and 21,515. So just considering the 20,000 to 21,515, that would be 2, 1. So how many numbers? There should be like 15 numbers that fall within that category. Right, there should be 15 numbers that fall within that category. Let me just verify this. So if I do 1 to 20,000, and then another one when it's 20,000 to 21,515. 1 to 20,000 should be 75, no, 50, 60. This is not the one that I was looking for. Yeah, it should be 50, and then this should be an extra 15, or an extra 10. So yeah, if you just have a power of 10 or a multiple of power of 10, then that digit that you have multiplied by your the number that you calculate with 3 digits, that would work. But then you just need to calculate from that multiple of power of 10 to the actual finish. And I think you can do that by doing, since the 2 is no longer in consideration, then you just do the next digit. So it's like 1515. How many ways to get to that? Using limit 4 suffix 1 2. I assume that has to be 10. That has to be 10. So 1515. Start is 1. Limit is 1515. Limit 4 is 12. That's 10. Yeah. So it's another recursive call to a simplified version of this calculation. Okay. Interesting. All right. I think I have it. Oof. So you have your powerful. So you have your answer based on this, and your answer is going to be multiplied by your starting digit, or the lower bound of your starting digit and your limit. No, this is multiplied by your. Let me see. It's whatever is smaller, your limit starting digit, or your whatever is smaller, your limit digit or your finish starting digit, I think. So this is 3 digits, power plus power 10. So this should be fine. So this should be 25. 25 should be multiplied. Okay, so I think I can call this start digit. Is going to be equal to the minimum of your limit and your first digit of your number. First digit of your number. How do you find your first digit of your number? Let's say you have your snum, and say you have your then string of your finish. So if you have your close power answer, so your first digit of your finish, so it's going to be integer of your fin string index 0. Okay, so that should be it. So if the limit is 4 and the finish string has starting digit is 2, then I'll pick 2 and it'll multiply by 2. So the answer should be times this s digit. And then you need to subtract from, you need to add onto it all the values. You need to add onto it all the values between that power, that multiple power of 10 and your finish. So finish minus equals your s digit. Well, can you just crop the finish string? Nah, probably not. So minus equals the s digit times your power of 10. It'd be close pow, 10 to the close power. Is that correct? So close pow is, alright, let's just print this out here. Print that finish. Alright, so yeah, I think this is too big. Should be minus close pow minus 1. Yeah, so it's 515, 1500, 15. Okay, so then you say that you're going to return your answer plus another self call number powerful int from 0 to this new finish. Limit s. I think that might work. And then say answer equals this. Then print out the answer. Alright, so this prints out, I think, 4, which is incorrect. 8, 50, 5. Huh. So close-ish, but not correct. And it's printing out some other crap that is definitely not correct. Limit. What is it doing here? print out the answer that you get. Alright, so I'm going to print out more than just the answer here. I'll print out the bounds here. Start, finish, limit, and string is always the same. Return 0. Alright, so I'm just going on here. How did the string get so garbled? Why did the answer get garbled up here? Close power is the length. So it's going from 15 to 215. So it's so this answer is for when the finish is start is 0, finish is 5. Interesting. So that's because it's calling the other one. It's calling it recursively. It's printing out then before it prints anything else. Okay. So 0 to 5. That should just be, well, from 0 to 5 and the limit is 6. The finish should be smaller than the start number. Should be smaller than the S string, so it should just be returning 0. Right, so if your call is start is 0, finish is 5, limit is 6, the finish, which is 5, and your S number is 10. Very small finish. Okay, then finish. Okay, so 215 is fine. 10, too small, 510. So it returned 0. Oh, it returned 0. Well, it returned 0. What's wrong with that? So 5, 6. Did I make a call? Oh, did I make this call incorrectly? Or did this not work? 10 S digit minus 0 to 5, 6 is your limit. Why did S change? S became 0.14. S became 0.14 during this call. Um, 0 to finish, limit S. And then S is Why did S change from 10 to 0.14? S is a string. Alright, so I'm gonna print out S. Before recurse. What is going on here? Okay, S is 10. Too small is 10. So return 0. And then, oh no, it's printing out the answer. The answer somehow was 0.14. So let's go answer. So close, so close. Okay, so why did the answer become a decimal? Because that should have returned too small 0. So 0 answer plus 0. Okay, so finish minus equals the number of digits. Finish minus equals the number of digits. Answer is 0.14. Answer plus self dot. I guess I always return 0 for all these. Maybe I do need to return something that's actually not garbage. So this one should definitely be returning 0. And then this one should be returning the answer. Want the answer. Oh. Is it this thing? The answer times equals the number of digits. Okay. No, the starting digit is correct. So the answer times equals your starting digit and then their finish. So when does your answer become this garbage? Answer equals answer plus self number of powerful integers, 0 finish. This limit with this new s. Okay. Some garbage here. Okay, so it does become garbage right here. Because the number of digits is 1. And then the answer is okay, it's right here. It's right there. So how did this go bad? Closest power minus the length minus 1. I guess that ended up being -1. So you have 215 so let's go and print everything here. Start is always 0, so finish limit s. So initial answer. So limit is finish is 6. No, finish is 215, limit is 6. And you have 10 as your ending. So 1 is your answer. That's fine. Finish is 15, limit is 6, 10 is your S. At that point, you should have 0 free digits. So if the number of free digits is equal to 0, limit S, free digits. That should be 0 free digits, but it's -1 free digits. How odd. Your 15 is your finish, 6 is your limit, 10 is your suffix. It's okay. If your free digits is -1 or less than this, if free digits is less than 0, return 0. Oh, Lord. Okay. Okay, so pretty darn close. So there's something wrong with this thing here. Alright, there's just too much printing out here. Let's go ahead and just make this invisible for now. So why did this calculate correct? So you have 6,124 124 is your, why is it printing out 124 twice? Why is it printing out anything? So right now it's printing out OK, finish, S num and S. Alright, this is not helpful. What I do want to know is the initial answer. Yeah, what the initial answer is. So it's going from 0 to 6,000. It's probably just the edge case. It's probably just the edge case. Where the bounds are the same. So I want to say your answer should be So it's giving you one too many. So here your limit's 4. So it's going from 0 to 6,000. Oh, okay, I see. I think I see. It's actually subtracting 4,000, but should be just subtracting that whole first digit. Yeah, it should be subtracting the first digit. It should be just removing it. How to remove the... It should be removing it. So it's not the minimum. It's probably it's the minimum to get what you. It's the minimum to get the multiplier, but it's the maximum to remove the digit. What if there's another way of removing the digit? What's another way of removing the digit? It's probably just something stupid like, or something simple like s digit finish minus the integer value of the first digit of the string times 10 to that thing. Alright, that definitely did not work. So the initial answer is now it's too small. Oh. Okay, let me go back to what I had before. So yeah, okay, it's doing stuff. So it should be subtracting out 6,000, and I should be dealing with 0, I guess. So yeah, so finish. I mean, I feel like that's correct. It should be subtracting out the biggest power of 10. That just removes that first digit. So why isn't that correct? Finish. Okay, it's integer value of the first digit of the finish string times 10 to the power of whatever. Okay, so it does pretty much one loop in that case. So it does 6,124, and there's nothing left over once you subtract 6,000 from 6,000. But then why doesn't it work? Why doesn't it give you 5? One gives you 4. So 124 has one free digit. That free digit should mean that there's 5 to the power of 1. Limit plus 1 to the power of 3 digits. But the initial answer is 1, and then 1 times the minimum of I see. It's because you're considering 1 as the multiplier. No, 4 as the multiplier. Alright, so if it was something where the finish is 6,000 and its suffix is 124. So it's like x124. So it could be 0, 1, 2, 3, or 4. I think maybe the way to handle this is if your first digit is if your first digit matches the limit digit, then you have to worry about this, but if it's bigger, then you don't have to worry about it. So if it's bigger, then you just multiply your number of digits times. Okay, so what's the logic here? So this logic is mostly for the edge case where it's actually the same value. So if the limit is smaller than the first digit, let's say finished digit. Finished digit is going to be fin integer of fin string 0 index. So if your limit is smaller than this fin digit, just return answer. Return limit plus 1 to the power of your free digits. Limit plus 1, which is 5 to the power of your free digits. I think this should be free digits plus 1. Limit plus 1. So 124, limit plus 1 is 5. 5 to the power of free digits plus 1, I think. Free digits plus 1. Okay. And then if it's not, then you have to do this, all this other jazz. Okay. Let's see if this, let's see what cases this fails at. Alright. Start is 1, finish is 971, end is 17. So let's say simple case, and so answer is equal to this. And I'll print the simple answer. Say limit 3 digits. Alright, so it doesn't go through the simple case. So this is the non-simple case. So let's print out that. Okay, so 9, 17, 17. There is one free, no, there's 0 free digits. Thought there should be one free digit here. Finish is 971. Limit is 9. 17 is S. There's 0 free digits. Okay, I guess that's fine. So there's 0 free digits. So you're multiplying, your initial answer is 1. And then 1 would be multiplied by the limit of, by 9. So that should give you 10. No, 1 should be multiplied by, yeah, 1 should be multiplied by 9, that gives you 10. And then you're thinking of how many times 17 is less than 71. There should be 1 time there. Okay, 17. 71, 17. And that one, it probably gives return 0. Right. Returning 0 for, let's say, this finish and this last one. But this should be returning 1. Yeah, it should be returning 1. So if the finish is smaller than, if the number of free digits is less than 0, but the finish is bigger than, if the finish is smaller or bigger than the S numbers, we should return that value. So return 1 if finish is bigger than S num, bigger than or equal to S num, else return 0. Alright, next wrong answer. Let's go ahead and remove some test cases. This is the 923 out of 932. Okay. Alright, so the start is 20 and the end is 11:59. Off by 1 again. So I'm calculating something smaller. So initially there's going to be 6 values. Why is there 6 values? So 5 is your limit. You have 2. You have 1 free digit. Okay, so the 1 free digit is this hundredths place. So therefore there's 6 possibilities in that spot. Okay. So your initial answer is 6. Assuming that you have like 0 as, it's like 0 and then one of the 6 possibilities and then 20. And now if you have 1 in your first spot, then it's how many numbers that are ending in 20 that's less than or equal to 159. So in that situation, you have no free digits. You have 0 free digits, so 1 so it should be 120 and 020, like 1020 and 1120. but it's not doing. Oh, this isn't. There's no way this should be working. So this should be 0, 59, 20. I don't know where the 0, 20, 20 comes from. So the initial answer for 159, 520, 0 free digits. Limit is, so for the 59, 20, 20. Huh. So, is it subtracting it? So if you're going from 0 to 1, 1 to 159, or 20 as your ending, um, 0 to 159, 20 is your ending. So you have 0 free digits. You should have 0 free digits right there. Limit is smaller than your final digit. Alright, what is going on here? So 59, 20, 20. 59 is your finish. When it calls 59 as your finish, and 20 as your I think there should probably just be a simple case here. If the length of your finish string is equal to the length of your string, then just return 1 if it's smaller. Return 1 if the finish is greater than or equal to snum, else 0. Alright, that didn't change anything. Surprise? Well, that did change something. It didn't call the last thing. It didn't call the 159. Didn't call the 5920 at 2020. Okay, so 159.20. So it's just doing this one wrong in this case. 159.520. So 159.520. It's just doing this thing wrong. No, by itself it's doing it right. But in conjunction with this is doing it wrong. Okay, so the initial answer is 159. Initial answer there is 2. Like 1, 0, or 120 and 020. But if you add another 1 in there, it doesn't work. So the initial answer is 6. And then it should be adding 2 more. It's only adding 1 more. So the initial answer is 6. Is this supposed to be 1 rather than star 0? Let me see if this is the wrong answer. If I have a star 0. Yeah, start should be 1. Okay. 1, 1. Start should have values. I fixed it. Case 6. Start should have values 1, 2. Let's go off the rails. Oh, yeah, this should be 1. Alright, it's calling infinite recursion. Not great. So okay, start. Oh, whoops! This should be start not equal to 1. Still off the rails. So it does 6. So the initial answer is 6. And then it should be calling it for 1 to 159. That should be 2. Like literally that was 2 right there. So the initial answer is 6 plus 2. Finish for 159, 520. 1 to 159. Let's go finish. Oh, interesting. It's doing it multiple times. Just finished 59. Just finish 159. So 159.20. So the answer there is 2. Answer plus the adjusted finish. So we subtract that out. 159.20. from here 1 to 159. You call it by itself. The start 1, the finish is 159, 1 is 5. That's number's 20. Answer should be 2. Recursive answer is equal to self. Number powerful int. Okay. Adjusted finish should be 2. The recursive answer there was 2. So 2 plus 6? Was answer originally 5? Okay, so how got 6 plus 2 is 8. So the answer was 8, and then somehow it got subtracted by 1. Output is 7. How did it get subtracted by 1? From 1 to the start. Start being 20. Oh my god, is that off by 1 that I had to consider, which I didn't consider? I think it should be start minus 1. So it's inclusive. Oh my god. Jesus. Alright, so if finish is smaller than your snum, it's too small, I think. Okay, these are all fine to check. So that could be at the very start. And then removing some of these prints. Right, let's see if that finish is smaller than your snum. Okay, actually you probably need to do the snum calculation before that. Okay. So what do we do here? So if your number, okay, yeah, this is changing it from worrying about the start to not worrying about the start. And then this is changing it so you have your finish string and your first digit. If the length of the string is smaller than or matches the length of the suffix, then that's just like a trivial case. Return 1 or not. And the closest power of 10 times find the number of free digits. If there are no free digits, then return 1. I wonder if this is necessary. I don't think this is. If the number of free digits is 0, then the length of the finish string is equal to or less than. No, equal to equal to. Yeah, that's probably when you actually have 0 free digits. So I don't think this is necessary anymore. Haha, 100%. Nice. If the limit, okay, powerful values between 0 and 10. If the limit is smaller than the finish's first digit, then your answer is just going to be that calculation. Otherwise, take your answer, excluding that first digit, you multiply by the lower bound of your possibilities here. What's the name for this? First digit. Okay, this is that. And then your finish is going to be ignoring that calculation and recursing. Let's see. To answer, that's your initial answer. Okay, so also here, this is your count of ways of using wild digits not including or not including first digit. So this is count 1 is this, and then this is the possible first digits. And then your answer is going to be equal to your count mids times your possible first digits. And then consider the ways between multiple power of 10 to actual finish. Example, like if your finish is 6,666 or 6543, and the above counted for 6,000, for 1 to 6,000. The below counts for 6,000 to 6543 using only counts for by counting 1, 2, 5, 4, 3. So that's the finish. Okay, so this is ignoring the top. So this is removing the first digit. The recurse answer is that, and then the answer is equal to that. I think this all works. Okay. All right. I like the other calculation of speed better, but all right. Summary. This is going to, well, you need to work through permutations and counting principles, but the key parts here is one, function of start to finish is equal to function from 1 to finish minus the function from 1 to start. Well, start minus 1 technically. To simplify the computation and not worry about edge cases from weird starts. And then so the other thing is handling simple cases where finish is smaller than your suffix or have same length, in which case simply compare the two values. Okay. And then interpreting the counts using number of 3 digits or wildcards. In between based on length of suffix and length of finish. Each wildcard is a multiplier by limit plus 1 to the answer. And then finally, handling non-trivial edge case where you count the number of values between the highest digit times power 10 and actual finish. And that's using a recursive call to where finish is reduced by that first digit. All right. Yeah, I'm not sure if I can explain this any simpler, since even I have trouble understanding what I did. Time complexity. Oh yeah, this is O of many hours for getting any solution, and O of, this is pretty darn fast. O of 1 is pretty much constant because you're dealing with like the number of digits and things. Yeah, O1 based on doing constant, based on doing calculations due to calculations based on length of digits and strings. And these are at most 15 digits on numbers. And space complexity, there is pretty much nothing. No real usage of data structures. Oh my god. And that's it.